Welcome to all of you. In last video we have studied how we can add two complex number or how we can subtract two complex number, or we can easily find the value of iota raised to the power 1 equal to iota. I already discussed this complete value. I write down here. Iota raised to the power 1 is equal to iota. Iota raised to the power 2 is equal to 1. Iota raised to the power 3 is equal to minus iota, and iota raised to the power 4 is equal to 1. So in this video we study how we can multiply two complex number. So two complex number, let z1 is x1 plus iota y1 and z2 is x2 plus iota y2. Two complex number is given and we need to multiply these two complex number. And here x1, x2, y1, y2, these all are real number. So just consider z is the product of z1 and z2. So if we multiply z1 and z2, then we get x1 plus iota y1 into x2 plus iota y2. So x1 into x2, we get x1 x2, x1 into iota y2, so iota times of x1 y2, iota y1 into x2, so iota times of y1 x2, and last value is iota y1 into iota y2, so iota square into y1 y2. In next step, this value is x1 x2. This one we can take iota common from these two value, so this become x1 y2 plus y1 x2. As we know, the value of iota square is equal to minus 1, so this last value become minus minus y1 y2. Okay, we can find the value like z1 is equal to z1 into z2. So we can arrange all the real part in one bracket and all the imaginary part in another bracket. So x1 x2 minus y1 y2 is real part of z1 z2, and iota times of x1 y2 plus y1 x2 is imaginary part of z1 z2. So in this way we can find the product of any two complex number. One important thing, whenever you try to find the product or division or addition or subtraction, always try to write the resultant complex number in the form of x plus iota y, means real part and imaginary part must be separate from each other. So you can check, we have real part and we have again imaginary part. We can take some example. Let z1 is equal to 2 plus 3 iota and z2 is equal to 3 plus 4 iota, and we need to find the product of these two complex numbers. So we can write z1 z2 equal to 2 plus 3 iota into 3 plus 4 iota. So 2 into 3 6, so first number is 6. Second one is 2 into 3, so this one is 2 into 4 iota 8 iota. 3 iota into 3 is 9 iota, and 3 iota into 4 iota, so total 12 iota square. So this value is 6, iota square is minus 1, so this become minus 12 plus 8 iota plus 9 iota is equal to 17 iota. So we write 17 iota. After simplification we can check 6 minus 12 is equal to minus 6 and 17 iota. So real part of z1 z2, after the multiplication we get real part of z1 z2 is equal to minus 6 and imaginary part of z1 z2 is minus 17. So whenever you perform some algebra in complex number, try to write the complex number, resultant complex number, in the form of x plus iota y. Like this one is x is real part and y is imaginary part. So first one is multiplication of two complex number. Next one is, you can check how we can divide two complex number. So for the division of two complex number, just consider two complex number. First one is z1 x1 plus iota y1 is given, and z2 x2 plus iota y2 is given. x1 y1 x2 y2, these all value are some real number, and iota is imaginary value equal to root over minus 1. So how we can find the division z1 upon z2? So first we write the value of z1 here, again value of z2. We can do here, we can write like z2 must be not equal to 0. We can't take the value of z2 equal to 0, because if you take z2 equal to 0, then this one is not defined. Next we need to write the resultant value in form of x plus iota y, but this value in numerator part we have some imaginary value, as well as in denominator part we have some imaginary value. So how we can eliminate this iota value from the denominator? So for this we can rationalize, and how we can rationalize? By the value x2 minus iota y2. Rationalize the denominator. So x2 minus iota y2, if we multiply in numerator part, then we need to multiply again in denominator part. You can check our numerator part is x1 plus iota y1 and x2 minus iota y2. So we can perform simple multiplication as we have discussed in last slide. So this becomes x1 x2 iota times of x1 y2. Next one is iota times of y1 x2, and again last one is iota into iota square and y1 y2. In denominator part you can check x2 plus iota y2 into x2 minus iota y2. So a plus b into a minus b is equal to a square minus b square. So we can write x2 whole square minus iota square into y2 whole square. Okay, you can check this value is x1 x2 and iota square is equal to minus 1. So minus and minus, this value become plus. So we can arrange this all real part in one bracket. So we can write x1 x2 plus iota square y1 y2 becomes y1 y2 plus, we can take iota common and we write y1 x2 from here, y1 x2, and x1 y2 from this part, and x2 whole square and again iota square, this value becomes minus 1. So this complete value become x2 whole square plus y2 whole square. But whenever we perform any algebraic in any two complex number, any algebra like multiplication, division, anything, then resultant value must be written in the form of x plus iota y. But how we can write this complete value in form of x plus iota y? So we can separate this value. So this complete value, write this complete value in one bracket, and with iota write this complete value in another bracket. Then you can observe, if x1 x2 is some real number, then x1 x2 y1 y2 divide upon x2 whole square plus y2 whole square. This complete value is real part of z1 upon z2. We can say this complete part is real part of z1 divide upon z2. I hope this one is clear. Okay, and if you consider this complete part, then this complete part is imaginary part of z1 divide upon z2. So in this way we can multiply two complex number and we can divide two complex number. In case of division, we need to rationalize the given complex number z1 upon z2, and after rationalization iota term will vanish from the denominator and we get some resultant value in the form of x plus iota y. So real part, and this one is imaginary part. So try to solve one question, after that everything will clear. If you try to solve one question is given, find z is equal to 1 plus 3 iota, like z1 upon z2, and z1 z2 are two given complex numbers such that z1 is equal to 1 plus 3 iota and z2 is given as 2 minus 4 iota. So what we need to do, first we need to vanish, means how we can replace the value of iota from the denominator. So we need to rationalize this value. So we can rationalize this value by 2 plus 4 iota and again divide upon 2 plus 4 iota. So try to find the complete value. 1 into 2, 2. 1 into 4 iota, so plus 4 iota. 3 iota into 2, so plus 6 iota, and last one is 3 into 4, 12. So last value is iota square into 12. Whole divide upon the denominator value is written in the form of a plus b into a minus b. So we can write 2 square minus iota square into 4 square. So try to find the value, and we get this complete value is equal to, this one is 2, and 4 iota plus 6 iota is equal to 10 iota. So write down directly 10 times of iota, and as we know the value of iota square is equal to -1, so this value becomes -12. Okay, and in our denominator we can write 2 square is 4 and iota square become -1, so minus minus becomes plus, so overall this one is 16. So we can write directly, so overall value is -10 plus 10 iota and divide upon 16 plus 4 is 20. So how we can separate real part as well as imaginary part? We can divide separately. So we can take -10 divided upon 20 plus -10 divided upon 20 plus 10 divided upon 20 times of iota. So what is the complex number? -1 upon 2 plus iota times of 1 upon 2. So if you try to find the value of real part of z, then this one is -1 upon 2 and imaginary part of z is equal to 1 upon 2. So in this way we can find the multiplication as well as division. So our next topic is equality of two complex number. Means when we can say if two complex numbers z1 and z2 is given, so these two complex number is equal. So when these two complex number is equal, so just consider we have two complex number. First complex number is z1 and second complex number is z2. If these two complex number z1 and z2 is equal, so we write z1 is equal to z2. So condition, we can write z1 is equal to x1 plus iota y1 and z2 is equal to x2 plus iota y2. So how we can equate these two? If two complex number are equal, then always remember the real part of these two complex number must be equal as well as the imaginary part of these two complex number must be equal to each other. So x1 must be equal to x2 because x1 and x2 are real part and y1 and y2 are imaginary part. So in this way we can say real part are equal to each other as well as imaginary part are equal to each other. So how we can solve some question? We can apply the concept of equality of two complex number in any question and we can find the value. So just consider question is given like if 2x plus 3x2, 2x1 plus, sorry some lagging issue is there, plus 3x2 plus iota times of, or we can take some simple question like this. If we write x plus 2y is equal to 2 not 2y, x plus 2 iota is equal to 1 plus iota y, then what is the value of x and y? So how we can find the value of x and y? We can equate the value of real part with real part. So let's say this one is z1 complex number and this one is z2 complex number. So how we can write? Real part of z1 must be equal to real part of z2, first part. So x is real part of z1 and 1 is real part of z2. So x is equal to 1 and imaginary part of z1 is must be equal to imaginary part of z2. So what is the imaginary part of z1? 2. So 2, write down 2 here. And what is the imaginary part of z2? Y. So y must be equal to 2 and x is equal to 1. So in this way, after equating these two values, we can easily find the value of x, some unknown variable like x and y. Okay. So one last, in next video we will study about how we can find the square root of complex number, and after that we will study about what is the meaning of geometrical representation of a complex number. So thank you everyone, and you can subscribe the channel for the next video, and see you soon. Thank you.